So, am I audible? Hi, am I audible? Yeah. Let us wait for 2 more minutes. Let's see how many joins. Uh, then we will start. Okay, so let's start. So hello everyone, my name is Rijay Mukherjee and I will be taking this NPTEL course, like tutorial or live session for NPTEL course on programming in modern C++. I am a research scholar in the Department of Computer Science and Engineering, IIT Kharagpur. So we'll be discussing few sample problems regarding week 9, like the lectures that are covered in week 9, and we'll be solving some basic problems, as well as we'll be at the end of the class we'll be like looking into some programs related to this week, which I feel it's important for you to understand. So let's start this week 9 course. Okay, so let's have a little recap first. What happened, what was taught in week 9, and what are the things that are relevant for this. So, so the things that were discussed in week 9 initially, the first part was file handling and input output to a program. So first thing was discussed, like how we implement these techniques for C. So we find for C, input and output to standard console. So console in the sense, uh, whenever you run a program, you can just give some input to it directly. So that is like the console from the terminal. So that is what we say console. And similarly, uh, inputs can be given via file. So for console, we saw these are the specific techniques that we use. That is scanf and printf. So scanf for input and printf for output. So this is directly for the console, direct input and output to the console. Now for file, uh, for file, first you need to open the file. So for opening the file, like it can be opened in few modes. Either it can be a like files can be of two types in context. One, it can be a binary file or a text file. So you will notice in your computer there are many files like of extension dat.dat. So those are basically binary files. So if you open a .dat file, you can see you will not be able to like understand what it is written in there, because it is generally written in a pure like binary format. So those kind of files, utility files, are generally are called binary files. And the text file is your normal text file. Suppose you have written a normal text and you save it as .txt. So that is a normal text file. Now here is a important question. You can open a text file also in binary mode. C plus that is allowed, but you cannot open a binary file in a text mode. That will cause an error. That will give you unknown errors that you will face while like runtime errors kind of things. So that is the issue. So files can be opened in both binary mode and text mode. Along with that, you need to specify what kind of operation you want to do with that file. So you can either do a write operation, read operation, write operation, or a append. So these are the three operations you can do. So along with that, there is the read plus, write plus, append plus operations, but we will just limit it to these three first. So in read mode, you open a file only to read the inputs from the file. In write mode, when you open a file in write mode, first of all, when you open a file in write mode, it truncates to 0. So whatever file, whatever thing that is written previously will be discarded, and you will open basically a new file when you open a file in write mode, just a blank slate to write your own stuff. But if you don't want to do it, you can use the append mode. So in append mode, you can open an existing file and write to it. So this is how you can, so you get the like best of both worlds. So you don't have to so in write mode, when you are like opening a file, that time the content of the file, if it is previously present, it truncates to 0. So when you open in open in an append mode, it means you can just modify the existing file without deleting all the contents. So that is a added benefit. So what kind of statements can one expect for reading or writing? So similar to scanf and printf, you have if scanf and if printf. So just like you are inputting int type, cat type, double type using scanf and printf, you can do the exactly same thing using if scanf and if printf for a file. Now these things can not only be used for your standard data types like int or double, you can also do stuffs like for a structure, you can also use these kind of statements. Other than that, you have getChar, getC, putC for only one character read and write. So here you can have multiple characters or variables that can be substituted inside the file or read from the file. In getC and putC, you can only get one character or read one character at a time from the file. Also, this file pointer is a very important thing. So it maintains it maintains a counter. Not only it points to that file, it also maintains counters like up to which portion of the file you have read, or up to which what was the last portion of the file you write to. So these kind of stuffs are basically done using the file pointer. Right. So these are how we are dealing with the file handling part in C. Now for C++, we had the exact same thing in the form of C in, C out. Right. Now for console, now there are already certain benefits of C in and C out corresponding to that from the C. So for first is for scanf and printf you have to uh, mention the data type while input or output. For C in and C out, you don't have to mention that, because you have already found out that these operators are basically overloaded, right? So for int, this has a function, overloaded function, operator function, operator this something for int, and similarly they have for double. So as a result, you don't have to mention the data type previously. That conversion happens explicitly, so you don't have to take care of that outside of your knowledge. So that is how C++ does the input and output stuff uh, in console mode. Now for file, you have that same kind of concept of file pointer. So like here one more thing can be done, like previously, like you have used if scanf and if printf. Here if you have a file pointer, if you can directly use this. Suppose you want to store int c equals to uh, int c, so you can directly write c. Suppose you have an int c, so you can directly write c is this is dash. So this will, what will do, it will just put the next int into this variable c. So these kind of options C++ allowed for a fast for doing it a very rapid way of doing it. So other than that, you have your put and get statements in C++, which allow to put our data in the file or get a data from the file. So this like you have if scanf and if printf, you have here put and get to do the same in C++. So this is how like input and output stuff gets done in C and C++. If you have any question, you can ask. Okay, so let's get to the next topic which was discussed. This one was given the term generic programming. So let's recap what happened last week, that is week number 8. You are introduced to the concept of template programming, right? So what you used to do in a template programming, you define a for rapid writing of programs, you can define a template T and write a code based on that T, and that T can be uh, anything from int, char, pointer to some user defined data type UDTs. So you have seen that you can write a min max code based on it. You can write a class based on a template, so that that class is valid for all, like int, char, both those kind of data types and things. So C++, standard C++ library provide us with, or known as STL, provide us with such templates. So these are available to you via C++. So what are these? You can have standard templates like vector, which you can consider it as an array. Then you have stack, you have queue. So these kind of templates you have, like class. Basically these are class stored in the standard library of C++. Other than that, you also have algorithms like sort, except sort you have some things like accumulate. Those kind of things you can have, where you do those sort of even you have those things like multiplication, iterator, those kind of things you have. For algo, like rotate, I forgot, rotate is another algo you have. Except that you have the third thing that STL have are iterators. So what happens? You have containers like stack, queue, vector. Then you have algorithms like sort, rotate. Now they can only store the data, and they can manipulate the data. To connect these two, you need a third thing called iterator. So using iterator, you can give options to these algorithms, through which it can manipulate the data that is stored here, because through this iterator it can access the data on which it can do the manipulation. So these algorithms needs an iterator so that it can do the manipulation. Otherwise, it cannot access the data. It is only able to manipulate the data. Similarly, containers can only store and access the data, but it cannot manipulate the data. So to join these two worlds, you need the iterators, right? So this a brief overview of what was done for week 8. So let's now get into the questions of like sample questions for this week. So you have been given this piece of code, uh, and you need to uh, provide what will be the output or any error if it is there. So you have, so let's look at the code one by one. So you have your standard uh, stdc, stdio and namespace. Then you have this a, b and c, and you have this character, these are all int types, and you have this character d that is written as this. So when you represent int as 0x067, so whenever you give this thing 0x in the front, it means it is a hexadecimal. When you give only 1 0 in front of it, it is basically a octet. And when there is nothing, it is basically a pure decimal, right? So but you notice here you are printing it a, b and c as mod d, mod d, mod d. You are not giving specific identifier for hexadecimal. So so this and this will all be printed as their corresponding decimal value. So let's calculate it. So 0x67 is basically 7 into 16 to the power 0 plus 6 into 16 to the power 1, that is 7 plus 96, 103. 067 is basically 7 into 8 to the power 0 plus 6 into 8 to the power of 1, that is 7 plus 48, that is 55, and this becomes this. So the correct answer, now let's come to this one, right? So what will happen here? So this will basically have a implicit conversion. So if a is equals to 65, then c is equals to 67. So basically c will be the thing that will be printed, because you see here we are printing mod c. So the correct answer will be 103, 55, 67 and c, right? Now if you have given here mod d, then it would have printed 67. So if we have used here mod d, it would have printed 67, the corresponding integer value for d of c. So the correct answer is option C. Okay, so let's go to the next one. So you have been given about this fseek function calls. So you need to do a match the column from this to this. So what does fseek does? Fseek basically you when you have the file pointer fp, it is used to traverse the file. So as you have seen for like an array, so if you have an array of 20, so you use a for loop for I equals to 0, 100. So this I is basically the iterator for traversal. So similarly, fp does the same for files, for in file handling. Now it has some placeholders. What are the placeholders? So one is seek set. What does seek set do? So these are all placeholders. So it points to the start of the file. So that is what seek set do. Similarly, you have seeker. It points to the current location of fp. Next you have secant. It points to the end of the file. So these are basically some placeholders that the file pointer that the file has. So seek set, seek current, secant. There are more, like these are some like a small section of that. So so the first part is your pointer, second part is your placeholder, third part is the placeholder, and the middle is basically whatever you want to give the value. So if it is positive, it will be added. If it is negative, it will be subtracted from this, from like this. Now let's just look at what does this like. So what so this is basically this moves the so okay, so what does this do? So this basically puts the set the f pointer as fp is equal to 10 plus 6 set. So this is what it does. This basically puts the file pointer at this location 10 plus 6 set. So which one of that? It moves forward. It moves the file pointer forward. Yeah. So it will be this. So this will be 1. Now what does this do? This basically sets it as fp is equals to seeker minus 10. So that is it sets the file pointer 10 places back from seeker. So that is move the file pointer from the current position in the file by 10 positions backwards. So this will be C will be 2. Next one is fseek fp0 secant. So this means fp is equals to fp is equals to seek end. So this basically tells the file pointer to go to the end of the file. So in this case it will be number A will be 3. Last is this. So what does this do? This says fp is equal to seek end minus 10, that is move the file pointer backwards from the end of the file by 10 positions, right? This will be 4. So the correct answer is option 2D. If you have any question, you can ask regarding this. So basically you have fseek. Fseek is a function which helps in navigating the file pointers. So there are it takes the file pointer as input, a decimal value, so that it can move either to the front or to the back of that placeholder or cursor, you can say. And there are 3 such placeholders, which are seek set, seek car, and seek end. Seek set points to the start of the file, seek end points to the end of the file, and seek car points to the current position of the file pointer. That is what it does. Then it calculates whether it has to go up or down based on the value in the second parameter of fseek, and that is how it is done. Okay, so let's go to the next one. So you have been given a piece of code. So you need to say what does this code actually does. So what is your opinion of this code? So we'll briefly go through this code and what it is trying to do. This is a C++ code, you can see. It is using fopen. So first it is declaring 2 file pointers, in fp and out fp. So it is opening a file.txt in read mode. So what does this check does? So it checks whether this file is so this file pointer return null if the file does not exist. So in that case, to throw an error, it does return -1. Next is this it is opening the second file in write mode, profile.txt, and it stores the file pointer is out fp. Now it is taking a integer int c. What it is doing now, what we are doing here, we are doing a if get c. What we are doing here is a if get c not equals to ef. So what does this do? So this picks a character from file my file.txt and it puts the value in C. So so each file, so how can you determine whether your file you have reached the end of the file? So each file has a special placeholder at the end which is called end of file. So when this get C reaches this position, it returns some value, and this C value checks whether it has returned to this last pointer, end of file pointer. Okay, so this is basically this is a standard code. So if you can just like keep it in mind. So this is the way to read all characters one by one in a text file. Until it reaches to the end, it checks. So after getting a file by if get C, it goes to the next pointer. So it goes to the next object. Basically the pointer infp gets incremented after this statement is executed, right? So now it checks this. If the character is a blank or a next line, it skips it, else it puts that character in procfile.txt. So basically and then it uses an if clause. So if you need to give if clause, because otherwise to close the text files, else it can get corrupted, suppose if you don't close the files, because you see it does lots of cleanup, not only so when you need to close a file, it does lots of cleanup like of these pointers things. So if you don't use if clause, it can ultimately lead to some corruption. So basically it is taking element. So it is basically taking an element from myfile.txt and copying it to procfile.txt without having the characters blank and next line. So it is just keeping these two characters and copying the rest to procfile.txt. So the correct answer in this case is it makes the exact copy of contents. It makes the option C. It makes the exact copy of the contents from file.txt to procfile.txt without spaces and new lines. Here. So in this problem, I will ask you all to remember this concept. This is a very important concept of how to read a file, because it checks this end-of thing constantly, and you can just directly use this code later when you are doing any operations for with files you need in your code or something. This is a very important concept of how to read a file. Okay. Okay, so let's go to the next one. So you have been given this code. You have to find out what is the output. So you see standard library of C or C++ has these kind of techniques like setf, that sets precision, or precision, set w, set fill. They uses this to format the text. So one pretty good example of formatting the text I can give is, suppose you have defined an int x equals to 56 and you say cout hex x. So this will print hex value of 56 instead of 56. So this kind of formatting C++ allows us. So there are formatting specifically for hex, octet, decimal, binary, also for setting the precision in case of floating point numbers or double. So C++ allows out with this kind of formatting tools. So in this case, such in this code, there are some such formatting tools that this program has used. One such is setf to set the precision, set fill to fill the empty place. So you have given uh, a set width of 10. So basically whatever will be printed will have 10 characters, not more than that, only 10 characters. Now you have also set fill. So if it doesn't have 10 characters, it will fill the rest as 0. Now you have also set the precision, show point. That means you are allowed to use the decimal point for 11. So in this case, the output will be 11.0000. That is your that it is determined by this setf standard iOS show point. This determines how many places beyond the decimal point it will be there, and this determines the length of the string, this thing, and this one is set the rest as w. So here you have used 1 2 3 4 5 6 7 elements. Now it has only place for 3 more. So the correct answer would be 00011.0000. So the correct answer is 4C. Clear? So this is basically an example of your how to use this precision thing. So suppose you don't have given 11 here. Suppose you have given input as 10 divided by 3. So in that case, it would have printed 3.3333.000. This is how it is done. Clear this one? Okay, so let's go to the next one. So you have been given this block of code, and you have to fill in the blanks here. So what you have here, you have your standard like this is for your standard console thing, and this is your for ifstream is for files. Now you have your main portion. You have this ifstream. Ifstream is used for files. You are for in C++. Now you are opening the file. You have a character int. So if file is open, so it checks whether the file has been successfully opened or not. So previously in C type thing, so here is your C type thing, you are comparing it with null. In this case you are using a standard C++ way of doing it. So you are using myfile.isOpen, whether it has been successfully opened or not, because it may not have been successfully opened. Suppose you don't have this file, so what will that happen? It will throw an error. For those reasons, this kind of sanity checking is present. Next, it checks whether my file is not currently pointing to EOF, that is the last file. So while it is not currently pointing to the EOF, what does it do? So the thing you need to print here is identify the appropriate option to fill in the blanks at line 1 such that the program prints the number of words in the file myfile.txt if the file exists, otherwise print unable to open. So the thing it wants to find out number of words it is present in this c file.txt. Now what is a word? Word is basically a character array separated from another character array in which between there is a blank. So basically a word is basically in this concept is basically a word is a chunk of text that is separated from another chunk of text, and in between there is either a new line or this kind of blank. So it checks that in this part whether the thing that is written now here is a blank. So if it is a blank, then we basically increment it by ++. Now to do this, one way of doing it was using that this thing, using this kind of statements like my file go to C, right? But see, in this case it can be any like char or int, those kind of things, but specifically we cannot do that, and this is a text file. So what way we can do it? So one way to do it is counting the number of spaces. So when you are writing a string or a line, you see you can have one word, then if another word, and it is separated by a blank. So that blank you calculate, and that will give you number of words. So in this case, what we will write here is C is equals to, so we are just getting one character at a time. So C is equals to my file dot get, that is this. So this will give you each character in the file. This will give you each character in the file, and you check if the character is a blank or not. If it is a blank, that means you increase the word count by 1. So suppose we have this statement, this is us, it has a blank here and it has a blank here. So whenever it encounters a blank, it increases I by I++. So initially if I is equals to 0, after getting this blank, it becomes 1. After getting this blank, it becomes 2. So the correct, and after experiencing this blank, it will become 3. So the correct way of doing it is just counting the number of blanks. Clear? So that is the way to do it. So this is the way to do it. If you have any doubt regarding this, you can ask. So let's go for the next one. So here you have, so these questions are quite different from the previous ones. So in this thing we come back to the world of generic programming slash templates, right? So here you have a template, and here you have the main function. This is your function min max. So what you are sending here as, so you need to find what you need to put here. So in this function min max we are passing in a few items. One is IRR. So IRR, what is IRR? IRR is basically a pointer, right? Or slash beginning of array. IRR plus this, so this prints the number of items. So size of AIRR plus divided by size of one pointer, so this gives the size. So IRR plus size, that is basically the end of array. Next you are sending two parts, max and min, such that and you finally printing it. So since you are passing this max and min and you are expecting that these values changed and gets printed here, so you need to use reference for max and min, right? So what are max and min type? Max and min type are type int. So it has to be so if you look here, max is taking a value from this and this, so it has to be t max, t ampersand max, t ampersand min, right? So this is to be the two of the values that will get updated. You can see it is getting updated here and here. Now next for the iterator, you will simply, so these are already pointers and you are already using pointers here. So this first is a pointer, and that is how it is working. So and last is also a pointer, so it is just taking whether the first is not equals to last, that means it has not reached the end. So in this case you will just print, just give itr first, itr last. That is the answer. So the first two are basically iterators, first and last are the iterators, and these are all the data pointers or the data references whose value needs to be changed. So the correct answer for this is which one? This one. So this is the correct answer. Clear? So if you have any doubt regarding this question, you can ask. Okay, so let's go to the next one. So let's look at this code and we will just understand what they are trying to do. So here you are like introduced to a algorithm accumulate. So here you have your compute function. Your compute function takes in a list of int type and it is returning some computation, that is accumulate. So what is accumulate? Accumulate is basically adding or multiplying, right? So here you see what is the computation you want. Your computation should be this. So basically you want a multiply, as well as in the main function you see you have an array 10.20 10 comma 20 comma 30 comma 40, and you are declaring this list of the list is of same size as that of this array. Now you are passing it into the compute. Fine, it is passed as a reference. Now how to use the accumulate function. So in the accumulate function you see first two will has to be the iterators, right? So first one will be li dot begin, li dot end. So this is the you need to give the like iterators, so the beginning and the end. Next you need to last one, basically you need to give, you are doing a multiplication. So in this case your result is in double, so you need to give it as a double. So multiplies double. Now you also want to divide the entire by 2. What is 2? 2 is basically 0.5. So this will be 0.5, the multiply. So this will give you the correct answer, like the correct answer what you are trying to compute in here. So out of all these options, the correct answer is option B. So one thing you may like ask, like okay, do I have to remember all of this? You have already seen sort, you have seen rotate, you have seen this accumulator. So my suggestion is you don't have to remember all of this, because these are very readily available on internet. Okay, so whenever you are writing a code, you can just Google. So so give me a function using which we can just add this whole thing up. So in practically you don't have to remember all of this. So why this is important to feel also to understand. The point is you need to understand how how these STL functions work. So this takes in two things. One is the first one is the start. Second one is the end. So these are the two iterators it requires. The third one, it requires what kind of multiplication it is trying to do, what kind of operation it's trying to do. That is the last one. So that is multiplier or double. And the middle one is the part like the common denominator, that's the half you need to do. So you don't have to remember all this, but how much you need to know is whenever you see the format, okay, you Google it, and what is the formula of accumulator, that you get the template, right? You get these are the things that are input as output. So whenever you just look at the input and output, you can just remember, oh, this has to be done like that. You don't have to just then further Google like what is a iterator. I don't know what is a iterator, that you don't no need to worry about. So that's why a study of this kind is important to understand how a iterator works. Accumulate function you don't have to understand because that is already partly written, but how to use the iterator for doing this kind of data manipulation, that is important to understand. Okay, so if you have any doubt regarding this, you can ask. Okay, so let's go to the next one. So you have been given this part of the code, and you have to fill this like what is the correct way to use this inner product. Now you see you have been given two lists. So and you have been given a function, and what is this? We have discussed previously. This is a functor, and we have discussed what is the difference between a function and a functor. So by elimination we will decide which one of them we need to use. Okay, this is a different way of doing it. So we need to do an inner product. It is given here, and such that the output it prints is 100. So that means what is inner product? So you have seen the inner dot product of vectors you have done in your mathematics class. So basically 1 into 3, 2 into 20, 3 into 30, 3 into 20. So that is 1 into 2, 2.20 plus 3.10. So that is basically 30 plus 40 plus 30, that is 100. Now you see you have been given two operation. One is operation 1, so which does this plus, so it does this plus operation, and you have this operator 2 which does this multiplication stuff between the two lists or array, you can say. So the first one will begin, we need to give the start and the end of the first list. So you need to give start and the end of the first list. So all of them are correct, the first two products. Now the next one, you need to give the first of list 2, right? So first of list 2 is given in 3 of them, A, B and C, A, B and C. So now you will ask a question, you can ask that why you don't have to give the second of end of B, end of L2. So the reason why end of L2 is not required, because when you are doing this kind of inner product, the theory is that both has to be of the same length, right? Now you have given the first and the last of our list for L1. So that will using that the compiler can determine, or the program when you are running, it can determine what is the length of L1, and it will use that length for L2 also. So it doesn't require the iterator, both the iterators for Li2. Fine. So now after this we have 3 options left, A, B or C. Now what? Now what does this value indicate? So this value indicates what will be the initial value of accumulator. So when it does the sum or multiply, you need to give some initial value. So in this case the initial value will be 0, because you are doing this addition. For doing the addition you need to put is equals to 0, and then you need to multiply. So in this case only option A and B remains because it has this 0 part. Now which of these had to be given? So now you see first one is a functor, right? So for a functor, which one we have to use, this or this? You need to use this for a functor. And this is for the function. So the correct answer is option A. So this is how by elimination you can find out which of the correct one is true. So if L2 has more elements than L1, program will ignore the extra. Yes, it will ignore the extra elements. It will just do for the the length of L1 up to. So that gives you how to use through elimination find out the correct one for the accumulator inner product you need to use. Okay. So for I believe the lambda functions are in week 9 or not 9, week 11. So instead of giving functors, you can also use lambdas for these statements. So lambdas can also be used. We will go through into the lambdas when I am discussing the week 11. I guess it has week 11. So then we will go through these lambdas and how to use lambdas in this kind of statements. Fine. So if you have any doubt regarding this, you can ask. I will go to the next one. Okay, so let's go to the next one. So you have been given. So now you will use another function that we have in our repertoire, that is copy. What does copy do? Copy is basically copying elements from one container to another. So this is what copy does. So here you have a character array which has the statement world. So now this statement, what does it do? It takes INTL, it's basically calculates the length of the array, the size of divided by size of one pointer. Next you are declaring a vector of character type of same length. Now you need to use the copy such that vector cvec also contain world. So here is the print function for vector c. Okay, so obviously it requires the same kind of things. One is the start end of first container and second is the start of second. So this is the format which will be there. So if you see in this kind of things, in this all the options, you have a copy, cr end, and cfig begin. So this is wrong, because car dot end, it is not present because it is a character array. It is not a vector or those kind of containers. So it don't have this start or end functions for its for this kind of thing. Next, this sends the address of the first pointer, it sends the address of the last pointer, and it sends the beginning of the vector. So this one is correct. So this takes the correct one, and this one is also correct. See, this is also doing the same. Passing the address and the first and the last, and the passing the address of the CVEC. This one is wrong because it is passing the CVEC at the first instance. So this one is wrong. So the correct answer is B and C. This is the correct format of copying like from one container to another. So note one thing, this copy functions acts not only for same kind of container. So character array is different and a vector is different. So it can occur, it can copy from different type of container to different type of container. So between a vec and list, a vector and list, it can do. It can also do between a stack and a queue. So this kind of thing it can do. So that is a like flexibility of this copy function in case of to copy one kind of data type to another, one kind of container to another. Okay. So if you have any doubt regarding any of these 9 questions, you can ask. We will go to the next part then. Okay, so let me just share my screen. Okay, so now we will discuss some programming questions so that you can learn how to apply STL in real world problems. So up till now you have learned about different STL containers and various algorithms. So these I have actually 4 programs I have designed, so that will give you some flavor of how to when and where to use which container. All are 4 different kind of problems, and it will give you a flavor of when to use which kind of container. Okay, so let's start. So let's start with this one. So here you have. So here you have. So the question is, you have been given a string expression. Write a program to examine whether the pairs and the orders of these are in correct order in the given expression. So basically suppose you have been given this or this, you need to find out whether they are in like the opening and the closing are in correct format or not. So suppose this example you see, you see you are opening a this and you are closing and you are closing this. Similarly, you are opening this and you are closing this. So this part we call a balance. So this has been only like whatever you have opened you have closed, there is no middle ground in between. Similarly, you have this, it opens here, it closes here. Similarly, you have this, it opens here, it closes here. You have this, it opens here, it closes here, opens here, closes here, opens here, closes here, opens here, closes here. So all of them has been correctly like well balanced, like whatever you are opening and they are closing in the correct order. Now let's see. So what do I mean by a correct order? So if this one is opened last, it should be closed first, right? So suppose you are writing an expression 4 plus 7 into 8 plus 5 into 3. So you see, since this has been opened first, this has been closed first. This has been opened first, second, opened last, closed first. Open first, closed last. So this is how. So if you formulate it correctly, now if you look this one has this, and this. So you see, when this has opened this, it is expecting, we are not closing it here. We are trying to close this one first. So this one is not balanced as a result. So you see, by now you should understand what you are trying to do. So what we are trying to do is here, basically opened last, close first. What does this mean? Whatever you are opening last, it has to be closed first. So this gives you an idea that we need to use a thing that we call stack. Why stack? Because stack has that same concept, last in, first in, first out, or last in, first out. So it has that same kind of concept, last in, first out. So in this case, we will have to use a stack to solve this problem. So we have used stack in STL. So we need to use that concept to do this. So let's look at a code which solves this program. So here you have a simple code which does the job. If you look at this, this is the main function, right? it takes a simple expression, let's say this, and it is calling a function called r brackets balanced. And this is quite self-explanatory, that whether it is balanced or not, it is just printing. Now let's look at the code once. So you have this brackets balanced function. It takes in an expression. So expression is basically this. Now you see, first we declare a stack to store these brackets, call in a temp bracket. Now we traverse the length of the string. So first we check if the stack is empty or not. If the stack is empty, then we push a bracket into it, right? Else, if the top is like the last element that has been put is this bracket, and the top element and the current expression that we are using is this, or current top is this and the current expression is this, current top is this and the current expression is this, then we are popping from the stack. So notice how you are using the stack. You have declared a stack, you are using its predefined function push and pop. If it is not this and you are expecting some other element, then we just push it, right? And that is the simple code to execute this one. So if at the end, if the stack is empty, then return true, that it is well balanced, else return false. So you see, you have this user, like the STL functions empty, push, top, pop, that is already defined for this stack. You don't have to write the code of the stack, you can just use this STL to do it. So this is what we call STL stack, and how to use that STL stack this program shows. So so what is this code basically doing? So this code is basically, so if you look only for this small part, so basically it has a stack. Now it initially pushes this to this, since it is empty. Now this one comes. So when it comes, this one, it checks, it compares it with this, and it sees that the current expression is not this, so it pushes it inside. Now it checks the current expression is this and this one is this, so it pops it, it empties it, empties the stack. Next it comes to this, it sees the top element and this element are same, like linearly opposite, so it pops this. Then it comes to this, it adds it because the stack is empty. When it comes to this, it adds it. It doesn't add it because it checks that these are polar opposite, so like it basically comes to this part of the question, check, and that's why it has the pop in that part. Okay, now let's take an example. Where we have an unbalanced one like this. So it basically, if we do this for this one, this example, so initially we will push this. Next it comes to this, it checks the top is not that linearly opposite, so it pushes it. Now it comes to this, it checks again that it is not linearly opposite, so it pushes it. Next it comes to this, it is not linearly opposite, so it pushes it. So every time this push gets executed whenever it doesn't match like this. Now it comes to this statement and it says that stack is not empty, so it returns false. So that means it is not balanced. So this is how you use a stack to basically find out this kind of problem, this balancing, whether the parentheses are balanced or not. Okay, so this is how you use like STL stack to do programming like for a stack. So this program gives you an idea. So basically the logic dictates which STL to use. So we will look at some other examples. So if you have any doubt regarding this, you can ask, then we will go to the next one. So if you don't have any doubt, I can go to the next one then. Okay, so let's go to the next program. So here you have, the question is, you have been given a string str and another string pat. So it says find the character in pat that is present at minimum index at str. If no character in pat is present, then print no character present. So this is a very confusing problem, but it is very easy. So you have this thing, this geeks for geeks array, character string, and you have another small string set. Now notice which are the elements that are common between str and pat. That is, s is present in both and e is present in both. S and E are present in both, right? So these are the two elements that are present in both. So the question asks which of these S or E are in the minimum index for this statement. So you see E is present in index 1, so 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, dot, dot, dot. And S is present in 4. So the minimum index character is, in this case, E1, right? Now if you look at this one, you have a string ADCFFAET and you have another string ONKL. Now you see none of them are present, none of these characters are present here. So we will print in that case no character present. Okay. So again in this for this like program also we will use some STL. What STL? Right, that is a question. So you know about this thing, hash table from data structure. What is a hash table? Hash table is like a table. So, what does a hash table allow you to do? Using a hash table, you can do mapping sort of thing. So you have, suppose you want to do this key search kind of thing. So suppose you have uh, like subject like history, and suppose there are 26 people present in this history class. So this kind of mapping a table maintains, right? So we will be using one such thing, like one such table for this. So STL provides us, so how will this table work in this case? So basically what our program will do, our program will iterate through the string and put all the unique elements present in it at its minimum location. For G is present at 0, E is present at 1, K is present at uh, 3, S is present at 4, F is present at 5, O is present at 6, R is present at 7, and rest are same, right? Now we will use this to iterate over this table. So first you will check whether S is present in the table. So you iterate through this table and you see yes, S is present at a table. So it is present at 4. So we will say that this is the minimum index, right? Minimum is equal to 4. Next again we will iterate for E. You see E will be found at 1. 1 is less than 4. 1 is less than 4. So mean will become 1 then. Then we will go to T and T is not present. So minimum index will be 1. So that is how this code will run. Now to do it, so to implement this table format, STL allows us with one topic, with one container. What is that container? We will look at. So STL give us in this case, so if you look at this code, this is the main program. So STL provide us with something called unordered map. So this unordered map basically implements the table. So you can go back and search about another map in much more details. You will find some good links regarding this. So what this unordered map, we define an unordered map of type char and int, right? Then we define that mean index at some say int max. So this is some max value. So this is some max value that is there in the system. Then we are calculating the size of both the strings. Then we are iterating over the first string, that is gigs for gigs in that code. So we are now populating the string. We are now populating each character in that unordered map. Is the unordered map. So it first checks whether the character is present already in the map. If it is not present, so this is a find is equal to end. It's another, you see this is a iterator which we have talked about already previously. So this is an iterator to check whether an element is present in the map or container or not, whether the element is present in the container or not. Next, we are putting that in the container, in the map at position, this the value of the index. Now we traverse the other string, that is pat. Now you see, first we the logic we described, that is we first check whether that element is present or not. If it is present and pat the minimum index, the index that is present is currently less than the minimum index, then we are populating the mean index. Finally, if the mean index is not that max int, then we print the minimum character, else we print that no character is present. So this is a simple example of how to use an unordered map. So a map will have a map or a table will have a key and its value. So basically these are a key value pair. So this we call it as table is basically a key value pair. So there will be a key and there will be a value. So in this case the key is the character of string and value is the location, sorry, not location, index in the string. So that is how the key value pair. So if you see here the key value pair is getting populated here. The key value pair is getting populated. So you are pushing the key here. So the key is basically the character, and the value is basically the index. You see the index here. Similarly, when you are finding the iterating the next string, similar operation is done here. So we are finding whether the whether it is present in the table or not, whether the string character is present in the table or not. If it is not present, if it is present, we check whether it is the index is smaller than the current mean index, and then we are updating it. We are taking the value. So you see here we are again putting the key and we are getting the value. So this is how a map is used in a STL. A map is used in STL. So this is how this is another example of how to use STL in real life. Okay. Any doubt regarding this? If you have any doubt, you can ask. Okay, so let's go to the next one. So in this case, this is a very fun exercise. Here we will be using another STL. So we have already used stack and map. Now you will be using another STL container for this. So you have been given two sorted arrays. So you have been given two sorted arrays, A and B, of length L1 and L2, and we can get a we can get a set of sums. So if you have been given two sets, let's say so like say you have been given this set A and B. So if you do a sum of each element with each element, so basically 1 plus 3, 1 plus 4, 1 plus 3, 1 plus 4. Similarly 2 plus 3, 2 plus 4, that will give you 4, 5, 5, 6. Basically it will come down to 4, 5, 6. So you have to find the nth element in the set considered as the sorted order. So you have to so you have been given value n, so you have to print what is there in the new array at position 3, so that is in this case 6. So this is what you need to print. Okay, so similarly let's consider another example. So you have this array and this array, so it will be 1 plus 20, 1 plus 22, 1 plus 30, 1 plus 40, 1 minute, 1 plus 20, 1 plus 20, 1 plus 22, 1 plus 30, 1 plus 40. Similarly 3 plus 20, 3 plus 22, 4 plus 30, no, 3 plus 22, 3 plus 30, and 8, 3 plus 40. Similarly this will be populated as 8 plus 20, 8 plus 22, 8 plus 30, 10 plus 40, and so on. So here you have been told find the number at location 4. So at location 4 it will be 1 plus 21, so number 21, 21, 23, 20, 1 plus 22, 1 plus 23, this thing, so it will be 21, 21, 23, 24, 28, those. So the third element in this case will be 25, that will be generated from this 3 plus 22. Okay, so this is how you need to do it. Now which STL to use? So what you require here is, so you will be adding both the loops, all elements with all elements, and storing it. So basically that will generate a long list, okay, a long array. So if you are so basically two loops to find combination of sums, right? Two loops to find combination of sums, and then remove duplicates, and then return value at n, right? Now STL will help you easily to mitigate this part, remove duplicate, because this will be very time consuming if you need to do it. So this, for this you will use a thing called set. Set is basically a array where duplicates are not present. Basically it is a sort of a binary search tree. So it is sort of a binary search tree, but it is basically used to do this kind of stuff. So if you look at the code what we are doing here for this part, so you have been given okay, this is a driver program. So you have been given two arrays, arr1 and arr2, and we are setting the size, calculate set of sums to this. So now you are defining a set. What the set does, when you insert something in the set, if it is already present in the set, then it is not added again, only one addition. Okay, so in this way the duplicate problem that is arising for you will not be present. So whenever you are doing this combination sum, array I plus 1 array ij, so this will be removed when you are using a set. Now you use a iterator to find out the nth element. So that is the part you need, nothing more. So simple, you don't have to think much about what algorithm you are using. Just using the correct STL, choice of your STL, you can just solve this problem very easily. So when you are using a set, you don't have to think about this removing the duplicate part. You can just write the code and use the two loops to find the combination. You just add it to the set. The number will get entry into the set only if it is not already present, and you then return the nth value in that set. Okay, so that is the logic, and that is how the STL you will be using to solve this problem. If you have any doubt regarding this, you can ask. So you need to think a little like these programs. These are very basic programs. These will just help you to understand when to use which STL container, because STL containers, there are lots and lots of containers, not only the set, map, stack, your vector list, these kind of things. There are lots and lots of containers that are available to you, and you need to use that to write your codes. So whenever you have so many options, you need to understand for which problem which container to use. So this is one way of understanding. These are few codes which will help you understand like which one to use when. Now one more interesting thing about this STL we will notice in the next problem. Okay, so this is the final problem. So what you have been given n bags with diamond in them. Now if each bag, like I bag have AI diamonds, so basically you have been given an array of size n, and each one has some non-negative value inside it. So basically I bag has done. So if you drop a bag P, so suppose you have this bag, so if you drop the bag P, you get the diamond P, and the value inside it becomes P by 2. So dropping a bag takes 1 minute, So you need to find the maximum number of diamonds that you can take if you have been given k minutes. So suppose you have been so here you see an example. You have been given n equals to 5. That means you have an array of 5 elements, that means your diamonds, and k equals to 3. That is 3 minutes you need to get by like dropping which bag you can find the diamonds in it. So you have 2, 1, 7, 4 and 2. Okay, so you have 3 minutes, so you have only 3 chances to find out to take the maximum. So what you will do it first you will your code should check this one. So you need to drop it first. So if you drop it, you get 7 diamonds, and the bag becomes 2, 1, 3, 4, 2. Next you drop, you see which is the largest, this one. So next you drop this bag, 4, 7 plus 4, and the array becomes 2 like half, 3, 2, 1, 3, 2, 2. Right, now this is second one, this is the first second, this is the second, and let's come to the third second. So you again drop the bag. So what is the largest element? 3 in this case. So it becomes 2, 1, 1, 2, 2. So it becomes 7 plus 4 plus 3, that is 14. So that is how you need to approach this. Now to solve this, you see at each step you choose the greatest number in the array, right? So stack is not possible, queue is not possible. So there is one more thing, if you have understood, like there is one more STL that you can use for this, that is called priority queue. So when you are like if you the term push and pop is for stack. Similarly for queue we have push and remove, you can say add or remove. So in priority queue you can use to remove only the largest element, right, from this array at each moment. So that will solve a lot of your problem for this this question. So let's look at the queue and like how we have used the queue. So this is your driver code. Okay. Now let's look at this one. So we have declared a priority queue. Now you are pushing into the priority queue all the elements. So the priority in this case will be the greatest number will be always at the top, and the lowest number will always be at the bottom. So you see now for each round, like k is the seconds, or let's say round, we are popping the top of the element, and then we are adding that to our accumulator or the answer, the max diamond, and then we are dividing the element which we have popped by 2, and then we are adding it again to the queue. This loop will work until and unless the k has a positive value. So this is how you use a priority queue to solve this kind of issues. So we have we have now learned about how to use a stack, uh, map, uh, what have we also used? Stack, map, set, and a priority queue. These are all STL containers, and also we have used iterators. So this is the things which we have discussed in the problems. So if you have any doubt, you can ask regarding any of this issues. That was the end of this class or live session. If you have any doubt, you can ask. Yeah, thank you. Okay, so we'll again meet next weekend, next Tuesday. Thank you for joining.